A pressure transmitter that reads correctly on the bench can still produce unstable or misleading control in a VFD booster system. Hydraulic surges, motor switching, poor cable routing, loop loading errors, moisture exposure, or an inaccessible process connection can all turn a seemingly suitable selection into a field problem. The right question is not whether a transmitter is generally durable. It is whether the configured unit can deliver usable pressure feedback under the actual hydraulic, electrical, thermal, environmental, and maintenance conditions of the installation. Start with the real pressure profile. Booster pumps do not operate at one steady value. Demand changes, pump sequencing, valve closures, non-return valve behavior, and pipe geometry can create short pressure events that never appear in a routine operating log. Record the normal control point, expected peaks, pump shutoff conditions, commissioning pressure, unusual demand conditions, and the transmitter's location relative to the pump and critical valves. Water hammer requires separate attention. A short transient can impose a mechanical duty that steady-state pressure does not reveal. The specification should identify the likely source of the surge and the available evidence, such as commissioning traces, hydraulic review, previous failures, or controlled testing. Compare that transient profile with the configured transmitter's operating range, overload boundary, and burst boundary. A stated pressure limit is a boundary for evaluation, not an invitation to operate continuously near severe conditions. Ask what event the supplier test represents, how often it may occur, and whether accuracy drift was acceptable afterward. The electrical path deserves the same discipline. A 4 to 20 milliamperes output is practical for industrial pressure feedback, but compatibility depends on the complete loop. Confirm supply voltage, total loop resistance, controller input type, terminal assignment, scaling, grounding, and shield termination. In a VFD cabinet, analog wiring shares space with switching devices, motor cables, relays, and power supplies. Noise, ground reference differences, excessive loop loading, loose terminals, and parallel routing beside motor conductors can distort the signal used by the pump controller. Bench testing is therefore only the first check. Verify low-end and high-end pressure simulation values at the controller input, then observe the reading while the drive switches and the pump changes speed. Record the cable type, route, shield treatment, power supply reference, input channel, software filtering, and scaling. A stable transmitter display is not enough if the PLC receives a different value. Environmental conditions also belong in the purchase specification. State the actual medium, temperature window, additives, sediment, cleaning practice, condensation risk, vibration, and cable exposure. An ingress marking describes a defined enclosure condition. It does not independently settle every question involving connectors, cable entries, washdown, immersion, or mounting position. The complete installed assembly must be reviewed. Finally, verify the mechanical interface and service procedure. Confirm the process thread, mating port, sealing method, mounting orientation, torque practice, cable bend radius, replacement clearance, and access for inspection. A compatible pressure range does not guarantee a compatible connection. These details should remain with the electrical configuration, drawing, test record, controller settings, and installation evidence. A strong RFQ describes the application rather than requesting a generic model. Include normal and peak pressure, output, supply, connection, medium, temperature, enclosure conditions, cable requirements, controller input, quantity, and known surge or EMC concerns. Release volume only after the exact configuration, sample evidence, installation conditions, and change control records are linked in one approval package. That traceability turns pressure feedback from a nominal component choice into a verified part of the pump control system.